So, for those who do not know me, some small introduction. So, I'm leading the company tmssoftware.com. I'm doing that since '95. Before, I have been studying civil engineering in electronics, and it will come as no surprise that I'm still also passionate about software, but I'm also still passionate about electronics, hardware, things like that. So between '95, where I was literally in my bedroom developing Delphi components, and now 23, we have grown to a team of 16 Delphi developers, 7 of which are located in our main office in Belgium. And we have 9 people working out of their home in different countries around the world, people who are really experts in a specific area of Delphi and in connection with other software. Our focus of the company is Delphi components. That's why you are here, I guess. And our focus has been in the beginning on VCL, and then steadily growing into FireMonkey components, web client application development, and also server development. That's what the BIS stands for. So today, we are going to talk about FNC, and to understand why I'm talking about something like FNC today, let's just quickly go back to the change and the development landscape between my bedroom in '95, where if you mastered Windows application development, I think you were pretty much the king of software development. While in '23, I think this landscape changed dramatically. And if you only master Windows, that's only, it's gotten a significantly smaller part of the software development world than it is today, with all the platforms that came to it. And I think we, as a Delphi developer, we can be extremely happy that at some point Embarcadero decided to also go into the direction of cross-platform development, and that introduced the FireMonkey framework for that, with compiling to natively to all the other platforms. So my first question is, who still remembers the year when Embarcadero introduced FireMonkey? Yes? Faster, faster. Yeah? No, it was earlier. No other guesses? Very close. I want to give something away. So, very close to 2010? No one a guess? I cannot give away when I have not. Yeah. So no one? Very close to 2010? 2011, of course. What will it be, a pen or a stress ball? Here you go. All right, so 2011, Embarcadero introduced the first version. It was Delphi XC2, and that featured targeting the iOS platform. At that time, if you still remember, it was through the FPC compiler. So now, fast forward to 2023, all these platforms, all these targets, and as a software developer, I think one of the rules in our company is, as a software developer, you have to be lazy. That means that you always have to find a way to make it yourself as easy as possible to be productive as you can. And that's why facing all these targets and trying to provide components that can be used in all these targets, we came to the realization that we could find a way to make it ourselves easier, and also make it easier for you, the developers of applications with Delphi. And that is the moment that we thought about FNC. So the reasons for these thoughts and what eventually came out of this is that we did want to offer the same components for the different frameworks, so for the VCL, for FireMonkey and all its targets, and eventually also the web. So if you are familiar with the component, it's flattening the learning curve if you just switch to another platform because your customer demands targeting other targets. It also helps if these are the same components, same classes, same interfaces, everything the same, to reuse your code. So typically we organize ourselves to exchange or reuse business logic, but with these techniques we can also exchange or reuse user interface code. If we have one reliable set of components, that also increases the robustness and the quality, because if there's some improvement to do, some fix to do, you do it once and it will be applicable everywhere for all the targets. And so it reduces the effort for writing new components, writing it once and using it everywhere. And actually, if you think about it, if you reflect about it, it is already this way to a certain degree with the VCL framework versus the FireMonkey framework. If we think about the T-edit in the VCL and the T-edit in the FireMonkey framework, as a Delphi developer, there is not much to switch or rethink between the two, and that applies to a label, a button, etc. You might remember, for example, if we think about a T-label in the VCL framework, there it is the caption that we use to set the text. In the FireMonkey framework, there we have the text property to set the text of the label. So you see, it is the goal to be very similar, but in the FireMonkey versus VCL framework, there are still subtle differences. So what did we do? What was our goal, our target? So one code base. Initially, it started with user interface controls, but we applied that technique as well to everything that concerns REST API access, to facilitate that, to make that easier, to use or reuse web code. We'll see that in a moment in the presentation, and of course also reuse business logic that gives you one learning curve. Talking about money, it's also a reduction because one license brings you everywhere with this concept. And so you have the freedom to choose where you will apply these components, be it VCL, FireMonkey, also LCL in the Lazarus IDE, that's the framework used in that free IDE, can be used in connection with FNC, and finally also the web clients created with TMS Web Core framework. And that brings you to all these operating systems. It can simply be used everywhere. If you think about here, Raspberry Pi, yes, because some of you work with Raspberry Pi. Again, only a few hands, okay, but you can install Lazarus IDE on the Raspberry Pi and develop Raspberry Pi applications from there and use our components in this IDE. So those of you who like to tinker with something like Raspberry Pi, I think this is something very nice. How did we create that? Well, that's basically the diagram that explains how we created this FNC framework. It's rather an abstraction layer than it is a framework. So we built that abstraction layer on top of VCL framework, FMX framework, LCL, and the Web Core framework. And it's a very thin abstraction layer. And if we code our components against that abstraction layer, that will make sure that our component will feel perfectly fine and work as a VCL component in a VCL application, and it will behave and work as a FireMonkey component in a FireMonkey application, and the same for LCL and web. That also means, and that's very important, that you can freely mix any other VCL component with an FNC component, because actually in a VCL application it behaves as a VCL component. So literally it is a VCL component at that time. And the same applies for FireMonkey. You can use it in connection with all the other FireMonkey components that come out of the box with Delphi. And when this FNC component is added to it, at that time it behaves as a FireMonkey component via that abstraction layer. If we bring this into categories, what kind of components do we have, do we offer this way? First of all, the non-visual components. There are a couple of them that are used in the FNC components. Of course, a large number of user interface components. Then we have the REST API access components, components that make it easy and encapsulate already everything that certain REST APIs offer. And finally, also components that interface to existing web technology. The most obvious example here is using web APIs like Google Maps or Bing Maps, these mapping services, and bringing that into VCL, FireMonkey, web or LCL applications. So these are the four main categories of these components. And I think this will probably be a very difficult question for you. When did we start? In what year did we start with the very first FNC component? Not sure if anyone here in the room has an idea. It was a little bit later, because initially, when FireMonkey was released, we started investigating the framework and see how it works, see how we could build components on top of that framework. And the initial step was actually to follow, let's say, how it was supposed to create components within the FireMonkey framework. If we look a little bit technically at that, a FireMonkey component originally was a set of objects, and you had the FireMonkey render engine that renders these objects on the fly. So initially, we used that approach to create FireMonkey components, but we have quickly learned that the more objects that are used, first of all, within the scope of the component, and secondly, within the scope of your application, that the performance degrades, and at some point degrades significantly when there are like thousands of these objects, little objects, like a rectangle and a line, and everything is made up of objects. When this amount of objects gets to thousands. And then was a moment to reflect back on, okay, how can we achieve a better performance like we are used to in the VCL? And so that at that point we introduced a VCL-like approach for creating FireMonkey components, and that gives a way better performance. And FNC is actually learning from all the experience, and it was actually in 2016 that we introduced the very first FNC component, and it was the FNC chart. So the fourth in the list. So between 2016 and now 2023, this is the series of products that we already created on top of this FNC abstraction layer. Where can it be used? Well, it can be used in the Delphi IDE, both with Delphi, but also RedStudio with C++ Builder. It can be installed and used in a Lazarus application. IDE, and finally it can also be used in the free Visual Studio Code IDE, and that's just for creating web client applications with WebCore. Just for my curiosity, who in the room has already experienced a little bit with WebCore? I see a few hands. Okay, so WebCore, the framework to create with Object Pascal and RED component-based development web client applications. So that framework, we also made it possible to use that from the Visual Studio Code IDE, with the advantage that the Visual Studio Code IDE can be used directly on Windows, Mac, and on Linux. So if your preferred development machine would be a Mac, you can run it there, use it there directly out of the box. So reflecting a little bit back to the basic concepts of that abstraction layer, these are the core things that we always keep in mind. We want to use the native operating system controls wherever possible. That means in a VCL application, an edit will always be the Windows edit class. So the real Windows edit control, same applies for the memo, the list box, the combo box, and go on. If we are using this, and fortunately, and a good thing that Embarcadero also did the same thing step by step in the FireMonkey framework, where they also use the native Mac controls more and more for an edit, for a button, etc. So the look and feel behavior is exactly what you expect in that specific operating system. So, and the same applies actually also for the browser. So there we use the browser-specific HTML elements underlying wherever possible. So use native controls with the ID goal that everything behaves as operating system specific as possible. We use the RTL, the Delphi RTL code, wherever possible, so everything will be nicely compatible. Platform APIs, so if some specific operating system functionality needs to be done, we want to use that directly with what the operating system offers. And remember that I talked about also exposing web functionality that is done through an embedded browser. And also very important here is that we always use the native installed browser on the operating system. So no external browser dependencies, etc., no extra payload to install. We use what the operating system natively has on board. And with that, I think also the advantage that whatever security updates the operating system is doing by itself on these web browsers, the application immediately benefits from. What did we do in that abstraction layer for non-visual components? So we start with the most simple components, the non-visual ones. Well, we added an interface for persistence. That means that at the TMS FNC custom component level, you get object persistence built in. It's an interface added to that T component level, and so you can persist anything immediately in JSON format. That is built in. And some extra smaller advantages. And that brings us to the user interface components. These are all descending from TTMS FNC custom control. And in this TMS FNC custom control, we surface everything that is the interaction between operating system and the user control. That means handling all the operating system inputs, the mouse, the keyboard, touch interaction, all these kinds of things. And of course, the control presents itself on the form via painting, and for that we have chosen or created an FNC graphics abstraction layer. So if we code against that layer, with the same code, it will render the same everywhere. And finally, last thing is also the data binding, where we use classic VCL style data binding. For the REST API access, also there we have a base class where all other components that specifically implement REST APIs descend from, and that base class has everything on board to do whatever is typically needed for accessing REST APIs. So that, of course, includes everything to do with the HTTPS requests, dealing with OAuth version 1, version 2 for authenticating against services. And it can be, that's also by option, you can code synchronously or asynchronously. So it gives you also the advantage to do asynchronous programming. And of course, the advantage that comes with it is that you never have a blocking UI when you opt for the asynchronous approach. Of course, it needs some extra, another way of coding, but at least you can achieve that you have, in these situations, never blocking user interfaces. And then finally, exposing web technology, like I mentioned, the mapping services, which are done through a browser. So what we basically need from there is interacting with that embedded web browser. We need, the most important here is that we need to interface from the Delphi native code to what is happening within that embedded browser. So what we want to do is inject HTML, CSS, things like that, inject JavaScript code, and not only inject it, but also on demand execute specific JavaScript functions that will then run in the browser. And that is, for example, tell the Google Maps to render itself in that embedded browser. That's one of these things. And at the same time, we also want to have the capability to react to certain events that are happening in that embedded browser. So think about clicking on a Google map that triggers inside that embedded browser a JavaScript event. And of course, we want to handle that JavaScript event at native Delphi application level, so that bridging between what's happening in the embedded browser and what's happening around it in your native Delphi application, that is what we bring into this TMS FNC custom web control, from where all the components that use these techniques descend from. So these are the four main categories. A brief overview on what is in the non-visual components. There is a full PDF generating library included. Non-visual components, you code again the FNC graph against the FNC graphics interface, and it generates on the fly PDF documents for you. So it can generate PDFs with embedded fonts, with compressed graphics, different graphics types, etc. So I have a first small demo about it, but I think you were waiting for a long time to see the Delphi IDE in action. So maybe what I will do first is show you how the FNC components can really be used everywhere. So here I have a new VCL application, and what I will do is I will add an FNC planner, so that typical agenda control that you are used to from something like Google Calendar or Microsoft Outlook. So this is the calendar. I dropped it on a VCL application. And as you can see here, it just behaves like a VCL component within that application. And I can drag, drop the events, etc. I can also programmatically add some item. So here I'm using a standard VCL component. And we will add an item from here. So in my code, I will create a new planner item. And that will be of the type the TMS FNC planner item. This way, and so I call the add item, and it asks a start time and an end time for this item. And so we'll make it ourselves easy and create an item with a duration of 1/10 of the day, which is like 2.4 hours, and we can give it a title, and let's set the title as Prague, and we add the text in that item, Delphi rocks. So let's see what happens when I compile that. And let's bring this time right. And so here you have seen that this item is inserted via code into this planner component. Don't be confused about donderdag, vrijdag, zaterdag. That's Dutch for Thursday, Friday, and Saturday, because in Belgium, I'm in the Dutch-speaking part, and that's how the days of the week are called in Belgium. So now I'm going to create a FireMonkey application, and I will do actually exactly the same. So this very same FNC planner will behave here as a FireMonkey component within my FireMonkey application, where I use the text property in this case to set the text for my button. And what I can do now, I can reuse that exact same code in my FireMonkey application. So let's run it. It behaves now as a FireMonkey component. And here is this component in my FireMonkey application. I do add, and as you can see, it's here and it behaves exactly the same way. As it is a FireMonkey application, I can, of course, choose all the targets that come with the FireMonkey framework. And within my Delphi IDE, I have here installed TMS Web Core framework. So that generates for me a Web Core web client application. And also here, I have this planner component available. Now it will behave as a web control. I add a web button that eventually maps onto a HTML button control. And same thing here, I just reuse that same code. So this is my web client application. It's all Object Pascal code with pretty much the same architecture. So we have a web form in this case, and we add controls like buttons, list boxes, edit controls, etc., but also this FNC planner. And obviously, this web application will run in the browser. So it will directly run out of your browser. Here, my default installed browser is a Chrome browser. So you have here that exact same planner with the same behavior. And when I click Add, you can see the same behavior in my browser. So I have in 30 seconds a web application for agenda management. That was a little bit loud. Let's reduce the sound somewhat. Okay. And that brings us back to the non-visual components, where I wanted to show you a first implementation where a PDF is generated on the fly. And here in this case, it is generated from a VCL application through that FNC PDF library. And one of the things that it can do is it has also, every FNC component has the ability to render itself on FNC graphics. And everything in FNC graphics can be rendered onto a PDF. That means that rendering controls on a PDF is really very simple. So I did an export to PDF. And here you can see the result of rendering this on the fly. We added a header to it and some extra text, etc. But this is an FNC gauge control and an FNC grid that is here rendered on the fly in this PDF directly from a VCL application. What we also did here actually was create a demo with the same code, and this code is here. This is actually the code that draws on that PDF. And that unit that draws that code on the PDF is used in the demo for VCL, exactly the same code in the demo for the FireMonkey application, and again, exactly the same code in a web application. So for example, here you can see draw text being used with some alignment, etc. So everything is drawn via the PDF library on the graphics layer and with the calls to draw text and controls, etc. If we have a look, and you can see it here in the business logic, it uses exactly that same code. And now I'm going to run that from a web application. So now here everything is compiled with WebCore to a web application. And what will happen here is that the generation of the PDF does not need any server side. The PDF will be generated fully client-side. So now everything for the generation of the PDF is happening within the browser. It is not going back to the server. And when the PDF is ready, it downloads it here. So I make this the Prague version. And when I open this file, you can see this exact same PDF, but in this case generated out of the browser in this web application. All right. What's more within these components? Well, we have also an SVG parser and renderer. So that means that you can use an FNC components SVG files everywhere. And I don't think I have to explain the advantage of using SVG files, because these always render sharp on whatever screen you are. JSON parsing is also something that is built in at that non-visual component level. And that brings us to the user interface controls. I explained that we have introduced the FNC custom control as a base class for that. And now I want to quickly highlight a little bit how this abstraction layer is dealing with the underlying framework implementations for the custom control and the graphics that are rendered within that custom control. So in a VCL component, I guess you are all familiar that with the tCanvas, which is the class that deals with rendering something onto the screen within your control. In the FireMonkey framework, we also have an tCanvas, but that's a completely different implementation. because that will use underlying the GDI or GDI plus or direct drawing on direct 2D on Windows. It will use the native, I think meanwhile it's the Metal framework on iOS, macOS. So it uses the underlying operating system APIs for drawing, but it abstracts everything at tCanvas level. But tCanvas in the FireMonkey framework is different from the tCanvas in the VCL framework. In the LCL framework, we also have a tCanvas, and in the WebCore framework, we actually added ourselves a tCanvas that is modeled after the VCL tCanvas for web controls running in the browser. And so here you can see a little bit in detail the subtle differences between the canvases in the different frameworks. So you see quite similarity in VCL and LCL. In FMX, you can see that there are quite some differences. So API calls or interfaces that are different. It's in the FMX a 32-bit color space by default, while the default is 24-bit color space in VCL and LCL. And you can see also a very important difference is a floating point coordinate system in FireMonkey, while in VCL, LCL, everything is an integer-based coordinate system. And the tCanvas that we created ourselves for WebCore, and which is based on the HTML5 canvas object, we kind of tried to have the best of both worlds. So we use what is nice in the FireMonkey framework, being the floating point coordinate system and the 32-bit color space, but still use the VCL, the familiar VCL classes like an T-brush, a pen, and the classic methods like polygon, rectangle, and so on. To draw images, also here in different frameworks, subtle differences between the classes that are used to draw images within the scope of your application. So we are used to using tBitmap for the Windows bitmaps, that's it, and tPicture for everything else. We added on top of that also the TMS FNC SVG bitmap, so that uses our SVG renderer to render SVG in a VCL application. And you see here important is the tBitmap in a WebCore application that obviously maps on the browser HTML IMG element, so that native element that is within the browser defined. And then we introduce in this abstraction layer some base classes, the FNC custom control to start with, and the FNC graphics, that is the implementation to do all the drawing, and underlying it will use the VCL canvas in the VCL app, the FireMonkey canvas in the FireMonkey app, the WebCore canvas in a web application. And we introduced some extra classes to deal with strokes, to do everything with line drawing, to deal with a fill, so that's the brush equivalent, and added several things more like texture drawing, complex gradient drawing is included in that. The graphics font was introduced because there are differences between the T font in the VCL application and the T font in the FireMonkey application. And so if you deal with TMS FNC graphics fonts, you can use the same class everywhere. And we used or introduced the FNC bitmap, which is also one class for dealing with images, and it's the same class you can use everywhere, VCL, FireMonkey, LCL, and web, and it will offer all these image formats for you right out of the box. So only one class to deal with. And here you can see an overview of the virtual methods that expose the operating system user interface interactions with mouse, touch, keyboard things, scrolling, etc. So if we create descending components from that base class, we actually deal with keyboard, mouse, touch on every operating system, including within the browser where that control is being used. Anyone knows why this percentage A minus thing is used within these methods? Yes, correct. We did it for a very specific reason. No ID. Actually, the FPC compiler, when you use it from a Lazarus IDE, the FPC compiler is way more picky about declarations of the parameter list, and using this parameter list, which is perfectly fine in, with the Delphi compiler, will throw a hint via the FPC compiler. So to avoid that kind of pointless hint, that is the reason why these defines are in the code of the base class. It's in the base class of the abstraction layer. You don't have to deal with it, so you can just use it as is. And here you can see the FNC graphic. So remember, that's the class we created for drawing on the surface of the component with the same code everywhere. And so these are all the methods that we make available for drawing all kinds of things. And again, if you code against that interface, it will work nicely and fine within a VCL, a FireMonkey, LCL, and a WebCore app. And this is here a summary, some screenshots of user interface controls that are created, all based on these standard or these base classes. A grid, the planner that I showed you, also a rich editor, an enhanced tree view. That's just a handful of many, many others that we created. And just to show you another small example, here I have a demo of combining a user interface control, an FNC planner, with that FNC PDF library. So here you see a somewhat more complex application based on that planner. So it's a kind of TV show agenda. And so everything for the TV show presenters is shown here in this agenda. And we have this export to PDF where it will render here the agenda for all the presenters. And that is based on the information that is shown in the FNC planner. And so that same demo we created can be used as a VCL app, as a FireMonkey app, as a WebCore app, as a Lazarus application. All right, and that brings us to the next topic, which is everything in connection with using REST APIs. So as I explained, it's a kind of a third category of components that make it easy to access REST APIs whatsoever. And we have, with these classes, created components to deal with popular public accessible REST APIs. Think about APIs like Google Calendar, Google Drive, but also Microsoft, OneDrive, and many, many more. Okay, so so that you can start using these REST APIs from these companies, without looking at the documentation of these APIs, but you can just use them using Delphi classes out of the box. And the classes that we have introduced at FNC level to make it easy to deal with all these REST APIs are here summarized. So basically everything starts with an HTTP request. So you can do the HTTPS, get, put, post, delete requests, etc. And so this is the class that captures all the details of the HTTP request that you want to do. So the method, the HTTP port number, host, the post data in case you are using an HTTP post, the headers that come with it. So everything is nicely encapsulated in this HTTP request class. And then, of course, to deal with the result from the REST API endpoint, this class just gives you back all the information that the server has returned after you have performed your request. So things like if it was successful or not, the HTTP response code, HTTP headers that are returned, capture it as text data or binary data. That is all covered within this response handling class. We have also a special class, which is the post data builder. So why do we have something like a post data builder? Who has already intensively worked with REST APIs here in this room? I see a couple of hands. So if you have used HTTP posts and the endpoint expects the data in some specific way, I think you can agree that sometimes it's very difficult to format the data you want to post to the server in the format that the server expects, because there are several ways to format your post data to post it to the server. For example, there is the multi-form post format, where you have multiple specific fields of information, or you can post binary base64 encoded data. So there are a number of formats, and it's always kind of tricky to have your post data exactly formatted the way your server expects it. And that's why we introduced the post data builder, meaning that you simply say, okay, I have this text with this name value pair, for example, or I have this stream of binary data. Just generate the post data in the format that the server expects, and the post data builder will do that for you, including when you have multi-form, multiple data in your form that you post, in splitting it in the different sections, for example, with the proper head and tail boundary identifiers. So it can be quite difficult, but here we made that easy for you. So you don't have to think about it. If you know what the server expects, it will format the data in the proper way with this post data builder. And then we have the class that actually does the work. So these were supporting classes, but the cloud base class is the class that is actually doing the work, that is performing that HTTP request and getting the result back. It might surprise you that there are maybe so many methods. That is, you can see also that this class features the post data builder. So at that class level, you can directly use a post data builder class to add the data. For example, think about using the Google Mail API to send an email via the Google Mail service. in that mail, you might have a need to add an attachment to your email. And so the post data builder is exactly what you can use for that. You add in your post data, for example, the email text itself, and then you will also need to post the attachment for that email. And so there is a perfect example where the post data builder comes in. But coming back to the other methods, something like execute all requests and get request count, add request, etc. Why is that? Because that base class can handle multiple requests at the same time. So you can give that base class like do 10 requests for, like say for example, send 10 emails. So you could just create the 10 requests for sending 10 emails and say, okay, class, do whatever you have to do and make all requests needed to send these 10 emails. That's one example of how you can use it. You can, of course, also use that class to send one request by one request, but dealing with multiple requests is also possible. You also see in the parameter async boolean equals true. So that means that by default, the HTTP requests will be performed asynchronously. So they will not block your user interfaces. But if you want, if there is some special need, just set that parameter to false and the request will be executed synchronously. And this here is, other than using these classes yourself for consuming whatever endpoints you might have yourself or public endpoints that we do not cover, you can use these base classes for that. But these are services that at this point we support out of the box. So we have ready to use components to deal with. You see that Google is quite popular. We have the most of Google services directly usable components to interact with these endpoints. But as you can see, many more. And so let's have a look in detail at these components and how they work. And I will add a new application here. I will make it simple and use a VCL application for that, where I have the FNC REST client component. So that is the REST client component. And as you can see, here is the request property. And so here is where we will set all the parameters for performing our HTTP request, like you see here, the many types of HTTP requests we can do. But we made it actually even easier than setting the properties right. We also implemented a design time editor to do that. And so here is our editor. And with that design time editor, we can already experiment with, I will add in a URL here. We can already, so this is an HTTP endpoint, so to speak. It's a very easy one. I can choose here the HTTP methods, and I can perform this request out of this editor. And so here I can already see the result from my endpoint, which is a JSON array. So I can, if I now set the properties, it will, if I will press OK, it will set the properties correct for my component. So I can experiment out of the IDE with the endpoint, see that my endpoint result is correct, And if so, it will, or I can fine-tune everything. And if it is correct, then I can immediately apply this as properties to my class that will then at runtime perform the request. So here you can see the formatted JSON, but some other interesting thing is that based on this result, on this JSON result, it will already suggest the Delphi classes that can be used to directly deal with the JSON that is returned. So if you look at this response, you see it's an array of JSON objects with these fields or attributes. And here is the corresponding Delphi class for that JSON object. So it will interpret your JSON and suggest the Delphi classes to use in connection with them, up till a generics list to deal with the array of JSON objects that is returns. Further than this, you can inspect the headers to be sent, that are received, etc. Here, in case you would need the post data, you would find back the post data from your event. So the message here is that this design time editor helps you to set everything right, so your HTTP request will be correct and as expected when you execute it at runtime. It saves you from setting the component, run, see what happens, check the results, etc. If something wrong, change, adapt the settings, run again, check it. You can do it all here at design time from the IDE. And here we have somewhat more an elaborated example. So here is an example where we access cloud storage. So remember that we cover Google Drive, Microsoft OneDrive, Dropbox, and a few others. And we also made it this way, that we can use these cloud storage services in an abstract way, meaning that if we develop an application to deal with the cloud storage, we just set one property and the API key, and I can actually show it in the code. So if I do the connection, so the things to set up based on the service that I want to use is this client ID, the secret, and the callback URL. And so you can see that other than this specific for the service, all the other code in this demo is cloud storage service agnostic. So I have here prepared, obviously I will not show the client ID and secret, otherwise you could access using our credentials, which is not the intention. So now I connect to Google Drive, which is my personal Google Drive, and you can see all the files that happen to be in my Google Drive account. And from here, you can, for example, trigger a download of that file. And when I now choose OneDrive, the Microsoft Cloud Storage, and perform the connection, it fetches everything that is in my OneDrive account. And in exactly the same way, I can also do here a download of one specific file in my OneDrive. So the message here is, if you developed dealing with the cloud storage service to upload, download, rename files, whatever, once, if you decide, okay, now my customer wants another cloud storage service, it's just one property to change, to choose the service, and then of course set the credentials, and that's it. With the same code, you are just up and running with another cloud storage service. All right, and then we come to the last type of controls, which is the controls that are using underlying internally an embedded web browser. So let's have a look. So as I explained, what do we need this for? And what are we exposing? So what we can do is, if we have some specific JavaScript code, we can use that JavaScript code out of our native Delphi application via the means of this embedded browser. We can also, if we have a JavaScript library that is doing something visually, it could be some specific chart rendering JavaScript library, for example. We can also embed that, use that as a visual control within our native Delphi application. And as I explained, what we need here is that bidirectional bridging. We need to be able to interact from our native code and instruct what will happen in that embedded browser, and the reverse. If something happens within the scope of the embedded browser, interact with events triggered from there. And so we have that base class developed to create this kind of application, and if you build on top of it, you don't have to deal with the underlying complexities of the different embedded browsers in the different operating systems. I have summarized it here. Here you can see on the different operating systems what underlying browser is used there. So in Windows, it's the Edge Chromium WebView, which is now standard. Microsoft ditched, obviously, Internet Explorer-based engine, and that's good. So now this is standard on board in Windows 10, Windows 11, and it is surfaced used with this WebView 2 in a Delphi application. In the Mac and iOS, this will be based on the WK WebView, which is actually built on the Safari, the Safari engine that is built into the operating system. On Android, it's the WebView, which obviously is also using the Chrome engine. On Linux and Raspberry Pi, it is based on WebKit, and we can actually use an embedded WebView within a web browser, a web client application, and of course there it will be the browser itself where this web client will be running. And so this here is a quick overview of that class from where you can descend and the most important functions. So here you can see execute JavaScript. So if there is some JavaScript function loaded into your web view, you can directly from this class execute this JavaScript code. And the call custom event is what is being called when you bind it to some specific JavaScript event triggered out of the browser. And you can also, with these load links, etc., you can inject HTML, inject links to references to JavaScript libraries, for example. You can deal with that all from your Object Pascal code. Something also very important is, are we actually here in this case in a situation where we need to be online, yes or no? I give one example. I mentioned there that we could have some specific JavaScript library for drawing a chart that isn't available in Delphi. I don't know, some kind of 3D special statistical chart whatsoever, and it does not happen to be available in Delphi. But we have an interesting, and in most cases free, JavaScript library to render the data you want to have rendered in your Delphi application. And so the question is, if we would use that library to render our data in that specific way in our native Delphi application, will we have the requirement that our application is online, yes or no? And in most cases, I would say like more than 90% of the cases, we can perfectly embed the JavaScript, HTML, CSS, whatever is needed, embed that as a resource in our native application and inject it in the browser when our native application starts, and we will not need any internet connection. We can use it directly out of the box like that. In some situations, it can be desirable and useful to use a library that is online for which we need an internet connection. Think about some library that gets updates, and of course, when we are in an online situation, we could, in these cases, automatically benefit from updates that are happening on the server, and we do not need to deploy anything new on the machine. We just use latest code that is fetched from the browser, but of course, in that case, needs an online connection. And that brings us to a first example of such an implementation, which is everything that concerns mapping. So you're all familiar with Google Maps, Bing Maps, Here Maps, Apple Mapping, etc. Meanwhile, there are many map service providers, and also here the idea of surfacing this as an FNC Maps control is you code once, you select the mapping service that you want with a simple property switch, and in that way you have not a real dependency on some specific mapping services. If the terms and conditions of Google Maps change tomorrow in a way that you don't like, you just switch the property to the service that has better conditions. Okay, so it avoids the lock-in situation with coding against a specific mapping service. You code against FNC Maps, and one property switch brings you to another mapping service. And so these are the services that we are supporting already today. So this is a brief overview of what is available from these mapping services. So visualization of all kinds of data on top of a map at some specific coordinate. Everything that concerns route calculations, drive from A to B, get the distance, the duration, also in some situations toll costs that might be applicable. Geolocation and reverse geolocation, so that is the conversion from a physical address to a geo coordinate, longitude and latitude, so that is also built in. And then some specific file formats that are typically used in connection with mapping services are also supported out of the box. And so I would like to also show you an overview of what can be done with this. And so I will also do this for reasons of simplicity in a VCL application, but I could as well do this from a FireMonkey application or a WebCore application from the Delphi IDE. So I added the FNC Maps control here on my screen. And for Google, we need a Google API key. And we will first of all use something free, so we don't need a key, and so we will use the OpenLayer mapping service. I will add a button to the form. An edit control, I will need that later on, so I'll already add it to the form. And what I will do here is we will bring Prague in the picture, and I will add a marker at Prague. So let's see what happens. And for that, I need an coordinate. So that is the class or the record better that represents a coordinate, and it has obviously a longitude and a latitude. So I looked it up via Google what the latitude is and what the longitude is of Prague. And so the latitude I set and the longitude I set. Here we go. Okay. And then what I can do is TMS FNC maps set center coordinates. So I will center my map onto Prague so that Prague comes in the picture, and then we add a marker at that specific coordinate, and maybe we can set a title obviously for Prague. So let's start this application. So we are using the Open Layers service. Default coordinate here, as you can see, is the Statue of Freedom in New York. And when I press the button, you can see here that it has brought Prague into the center. Now, what I will do is I will do exactly the same. Now I will reuse that code, but instead use the Google mapping service. But obviously I need to set my Google API key, and let's see that everything is so what I do is fetch the value of the key from my edit control, and you can see that I made it this edit control with password characters. So it's still now in Open Layers, and I have here also with password characters my Google API key. I paste this into my edit control, and now of course I forgot something. Of course I need to set my maps service to Google Maps. So here you can see the identifier that set different mapping services. So here we will use Google Maps. So that makes the mapping control switch from Open Layers standard to Google Maps. So first I need to get my API key, so copy it to the clipboard, paste it in its edit control, and then execute the code. And okay, so now you see the effect that it has switched with Google Maps and shows Prague on the map. But the point is that you can use exactly the same code as I used with Open Layers, that you can use that code with Google Maps and any of the other services that we support. A somewhat more complex example. It would take a bit too much time to code that from scratch here. So we will also use Google Maps. And so here you can see the entire world map. You can see that we have drawn some arrow, set some marker in a different color. We can use overlay views on a specific area of the map, or we could also embed things like that. But what we could also do is here we use the feature of map marker clustering. So what we did here, it's like a random set of locations where there is a McDonald's restaurant. And you can see here that we are using clustering. So within this area here in Austria, for example, there would be too much markers close to each other. So Google Maps can cluster that into one marker, indicating there are 8 markers within this area. And so when I click it, it will open automatically with the details. When I zoom out again, you can see that the clustering is taking place or going back into all the detailed markers. So that's just one example of using Google Maps with marker clustering and some overlay features. Here is another demo, and this demo shows you route calculations. It's the same concept. So let's maybe calculate the route from where I live, which is in the area of Kortrijk, Belgium. And let's see how far. I think Prague will be sufficient. Driving, show directions. So let's see what happens. So this would be the route that is suggested when I would drive with the car. I took the airplane, of course, but when I would drive with the car, this is how much time it would take me. It has here 6 hours and, or better 6 hours and 20 minutes for a total of 986 kilometers. And as you can see, it suggests that I take the highway to benefit from no speed limits in Germany, which is good. All right, and then to finish off, mapping services is one thing, but you can use so much more in with web technology in native applications. Here we have another component that is used to generate QR codes. It's actually based on a JavaScript library. It can be used offline. And so when I, for example, add this URL to my edit box, if you would take your smartphone and scan that, it would bring you to our website. This just another idea of how you can surface existing web technology in your web applications for your benefit. And a final example that I wanted to show you, which is same concept. It's the concept of reusing existing web technology. And here we have reused it for creating a math formula editor. So maybe for most of you, it's already a long time ago that you had to deal with this kind of mathematics. But if in your job you still have to deal with it, here with this library, you can enter all these nice, complex mathematical formulas. And yeah, I enjoyed it back in the days, and I still love how nice it is to play with these mathematical formulas. And so if you have a need for it in your application, that is also actually added in no time, thanks to reusing web technology within the scope of your native application. And with that, I think I'm kind of perfectly on time to finish this presentation. My conclusion, seeing all the possibilities that are available for us Delphi developers, I think still 28 years after Delphi was released in '95, I think it's still a wonderful time to be a Delphi developer, and that we are fortunate as a Delphi developer that there is such a wide range of possibilities where Delphi can take us, whether it's still a VCL application, whether it's a VCL application that is using web technology embedded on the fly, whether it's a native cross-platform application, whether it's a server application running on a Linux machine, whether it's a web client running in a web browser created with Object Pascal. I think the possibilities are only limited by our own ideas and creativity. So thank you very much for your attention. If there are any questions, you can ask them here, or if it's more convenient, you can also ask it during the breaks. And if you ask nicely, I still have a couple of pens and anti-stress balls. So I can also give that to you during the breaks. I don't want to take them back to Belgium. All right. Any questions there might be now? Yes? Okay, so indeed you're correct that when you want to target Linux, we work through FMX Linux. So as a FireMonkey application, it will run on your Linux machine. The one thing here specific is, of course, that there are many different Linux distributions. In our development, we always test against Ubuntu. So I'm not sure if it is also Ubuntu. Okay, then I think for the specific things that you have seen on your machine, to be in touch with our technical support, and then yeah, we can see what exactly might be missing here. Maybe it's something in the component, can be. Maybe it's something in connection with some graphics driver, who knows? It needs to be figured out. But the good thing is that you're also on Ubuntu. We all sometimes get requests from quite exotic Linux distributions, and that makes it a kind of hard to have all these distributions. We kind of count on FMX Linux, but I also think, I'm not sure, maybe Stephen can fall in what specific Linux distributions are really supported from FMX Linux. Yeah, Ubuntu is certainly among them. I think Red Hat also. Yeah, yeah. But I would invite to be in touch with support, and if it's Ubuntu, we can test it on our machines and check whatever might be happening. Okay. For those using Lazarus, you can also use Lazarus directly on the Linux machine and compile your UI application on the Linux where your Lazarus is running. That's also an alternative possibility. If there, okay, other question? Yes, yes, correct. So it's both Delphi and C++ that is supported. Yes. No more questions, then I give the word back. So thank you very much, and be in touch during the breaks.